Hello, and welcome to this edition of the CSIAC podcast series. In this episode, subject matter experts will examine entity resolution for the cyber domain. The foundational level of situation awareness lies in the perception of the surrounding environment. In cyberspace, this is an ability to enumerate and identify elements of the cyber terrain. Devices emit signals and negotiate for services, but they do not share consistent features, making it difficult to uniquely identify which hosts are active over a period of interest. Use of a cyber entity resolution approach and blocking technique can bridge this gap. The technique is based on the construction and comparison of periodic snapshots of host segments built up from multiple log files. We'll present results from an open dataset in a cyber situation awareness prototype that visualizes the host segments and discuss its efficacy at discovering hosts. We'll also describe a supervised machine learning approach to assist in entity resolution. An experiment using server logs from an enterprise network to resolve hosts between snapshots was performed. Properly resolving entities in the cyber domain is a necessary condition for enumerating and identifying elements of the cyber terrain. Full visibility requires a wide array of sensors deployed over the network and spanning the physical and logical layers of the system. Data from different sensors can only be used in concert if we are able to associate occurrences of common events or entities. Entity resolution is the practice of finding and linking records of the same underlying entity across datasets. This problem is widely researched in other domains, but has been less formally acknowledged in cybersecurity. It is important because without ER, the number of entities is artificially magnified. In cybersecurity, this translates to a perceived increase of the attack surface. More importantly, there is no way to associate observations made at different times and places on different sensors. Entity resolution is what enables multimodal analysis of disparate data sources. Contributions of this approach are a formal problem statement for ER in the cyber domain, an approach to incorporate ER into a larger security process, a preliminary implementation to demonstrate the blocking concepts of host segments, and a roadmap for refining the technique for future deployments. Entity resolution is the process of disambiguating and linking data records to real-world individuals or entities. In the intelligence community, tracking a potential threat actor requires identifying aliases used by the individual and attributing activities and assets assumed under these aliases back to the particular individual. ER must also be able to distinguish observations of multiple individuals with similar or identical names. Real-world applications of ER must be able to tolerate errors and missing data. In the cyber domain, a host may manifest in various logs by its host name, IP address, MAC address, or other form of ID. These identities are not fixed. When a host connects to a network, it likely gets a dynamically assigned IP address different from previous connections. IP addresses are reused by different hosts. Host names and MAC addresses can also change. It is not uncommon to have collisions of host names and MAC addresses on a network. The volume of records, along with the rate of change, makes ER in the cyber domain quite challenging. The goal of ER in the cyber domain is to associate a set of time-stamped events extracted from different data streams to the real-world entities that generated them. To maintain situation awareness of their assets, network owners often run scanners to enumerate active hosts and their services. This provides a snapshot of the network at a particular point in time that is useful for static operating environments. Many enterprise networks deploy endpoint security and systems management software on hosts that act like trackers. When dealing with a dynamic operating environment, it is impractical to run scanners and agents continuously at a high rate to achieve good coverage over time. Hosts in this environment often connect and disconnect from the network via different interfaces. They have shared interfaces, dynamically assigned IP addresses, and are shared among multiple users and contain various aliases. Entity resolution must be applied for data cleaning, a prerequisite of data mining, to correctly correlate hosts across multiple data streams. Entity resolution techniques must be able to overcome the challenges of working with raw cyber data, such as large quantity, lack of common fields across data sources, and no safe assumption about the rate of change for host identifiers. Newer ER methods have attempted to overcome these challenges by applying comprehensive data-agnostic approaches to host enumeration. ER strategies fall into two categories: deterministic and probabilistic. Entity resolution of network devices using deterministic graph features can resolve network paths between entities. Deterministic approaches bin records into two mutually exclusive groups, matched or unmatched. This approach is typically quite sensitive to match rules and fails to capture record matching for linkage fields that only partially agree. Probabilistic approaches allow for fuzzy matching of linkage fields that partially agree based on a particular threshold. A seminal paper on probabilistic ER provides a helpful contrast of deterministic and probabilistic record linkage approaches using lists of names for epidemiology. Work improves upon these results by realizing two assumptions. Individual fields common to both datasets are completely observed, and the field agreement indicators are conditionally independent within the subsets of record pairs. A probabilistic ER technique using similarity flooding extends previous work on deterministic rule-based ER to resolve duplicate entities applied to network path estimation. The strategy combines both deterministic and probabilistic approaches to ER in an effort to capture all possible record matches. On behalf of the CSIAC, we would like to thank you for viewing this podcast. We hope you found the content useful and informative. If you would like to provide us with feedback, please comment on this video or visit our website at www.csiac.org, where you can also find additional content to review. Thank you.
Did you know that CSIAC offers free monthly webinars featuring experts in the areas of cybersecurity, software engineering, modeling and simulation, and knowledge management? Come see leading industry professionals talk about industry practices and leading research. Make sure to visit www.csiac.org/webinars in order to subscribe to our mailing list and see when the next webinar series is available. There you can also watch previous webinar series to catch up. Visit www.csiac.org/webinars.